If you want to factor, first thing I want you to notice is that in all 4 of these problems, you're starting off with 4 terms. So 1, 2, 3, 4, or 1, 2, 3, 4. If you're going to factor something with 4 terms, you're going to group the front 2 and you're going to group the back 2. And ultimately what factoring means is to turn it into a multiplication problem. I'm going to color code that grouping. So starting off with this first problem, I'm going to group the front 2 and the back 2. So I'm just saying, I've got my blue ones in the front and my red ones in the back. Focusing on the blue ones, we want to take out whatever's in common to both. This is W times W, and that's 4 times W. So what's in common is a single W. So I'm going to take a W out front, and then I'm going to put in parentheses whatever's left over. So if you take a W out of W squared, there'd still be a W. Yes. And if I take a W out of 4W, there'd still be a 4. So putting in parentheses there, what's left over, that would be W plus 4. I'm going to do the same thing to the back half. So focusing on the last 2 that I have in red, 2W and 8. 2 and 8 are both even. And so since they're both even, I'm going to take a 2 out. So taking a 2 out of 2W, again, just write down what we're going to have. Okay, 2. Taking a 2W out of 2W, or 2 out of 2W, I'm going to have a W. And a 2 out of 8, I'm going to be left with 4. You can redistribute to verify. W times W is W squared. W times 4 is 4W. 2 times W is 2W. And 2 times 4 is 8. It's not a coincidence that the leftover is matching. I have W plus 4 here, and I have W plus 4 here. If they're not matching, you did something wrong. So then we're going to take out what's in common to the blue and the red. So both the blue and the red have W plus 4. So I'm going to take W plus 4 out front. And then in parentheses, I'll put what's left over, which is a W and a plus 2. And now it's factored. Notice again, the original was a bunch of terms added together, and now we have multiplication. So factoring, we turned it into multiplication, and that is our final answer. If you want to verify your solution, you want to double check that you did it right, I can take what I got as an answer and multiply it back together. So if I FOIL this, W times W is W to the second. W times 2 is 2W. 4 times W is 4W. And last, 4 times 2 is 8. If you compare this to the original, notice it's the same. It does say 2W plus 4W versus 4W plus 2W, but we still have the same terms. Okay, so I'm going to do 3 more examples. This one here, if I group the front 2 and the back 2, so my fronts are the blue ones, the backs are the red ones. What's in common to x to the third and negative 2x squared? They both have an x to the second power. So I'm going to take an x to the second out, and if I take it out of x cubed, I'll have an x left. And if I take an x to the second out of negative 2x squared, I'll still have negative 2. So you put what's left in parentheses. Grouping the back half, this time I'm going to cheat a little bit. I know they're going to match. So whatever I decide to take out of the red, the leftover is going to be x minus 2. So I'm going to go ahead and say, well, I know that's going to be x minus 2. So what did I take out of 6x and negative 12? I took out a 6. Let's re-verify. 6 times x is 6x. 6 times negative 2 is negative 12. The blue and the red both have an x minus 2. So I'm going to take an x minus 2 out of both the blue and the red. And the leftover is x squared plus 6. I've rewritten it as a multiplication problem, so it's factored. If you FOIL, you can double check that you did it correctly. So x times x squared is x to the third. Outside, x times 6 is 6x. Inside, negative 2 times x squared, negative 2x squared. And then last, negative 2 times 6 is 12. Okay, so these two here, I'm going to group the front two. So I've got my blue ones in the front and my red ones in the back. What's in common to 10 and 15 is 5, because 5 fits into both of those. And then for x to the third and x squared, they both have an x squared. So I'm going to take out a 5 and an x squared, and I want to write down what's left over. So 10 divided by 5 is 2, and then x times x times x, I take out an x times x, I still have an x. So I have 2x, and then 15 divided by 5 is 3, so we have minus 3, and the x squareds were taken out, so all we have is minus 3. Again, just kind of using the fact that I already know that whatever I take out of the red, the leftover is going to be 2x minus 3. I'm going to go ahead and put what's going to be left over. The reason I'm doing this third example is in the other ones, I factored out a positive number. If I take out, because what number times 2 gets me back to 12? That'd be 6. But if I take out a positive 6, 6 times 2 would get me back to positive 12. And 6 times negative 3 would get me back to negative 18. So it's not going to be a positive that I take out. I'm going to take out a negative 6. So let's redistribute to verify. Negative 6 times 2x is negative 12x. Negative 6 times negative 3 is plus 18. Okay, so the only way I could get these to match is to take out a negative. Now in the blue and the red, they both have a 2x minus 3, and the leftover is 5x squared minus 6. If you wanted to verify, you could FOIL this together and you would see what you have is the same as the original. Okay, so last example, this one also has just a little tiny twist to it. Still starting off with grouping the front 2 and the back 2. What's in common to 10 and 2? 2 fits into both of those, so I'm going to take out a 2. And then x times x and x, they both have an x in common, so I'm going to take out an x. So 2x comes out. What's left over, 2 times 5 is going to get me back to 10, and x times x back to x squared. Now here, I take a 2x out of 2x. That does not mean 0 is left. What would you have to multiply 2x by to get back to 2x? Nice job. So that is a 1 left over. So if I take out a 2x, notice there's still a 1. Let's verify 2x times 5x, 10x squared, 2x times 1, 2x. Okay, now we're on the back half, and we're looking for what's in common. They both don't have an x. What's the biggest number that fits into both 5 and 1? 1. So I'm going to take out a 1. You have to take something out. And if I do take out a 1, 1 taken out of 5x, it's still 5x, and 1 taken out of 1, it's still 5. Let's redistribute to verify. 1 times 5x is 5x, 1 times 1 is 1. We see that both the red and the blue have 5x plus 1. So we're gonna take that out front. And so what we have left over from the blue and the red is gonna be 2x plus 1. So this factored is 5x plus 1 times 2x plus 1. This is my final answer, but if you multiplied first plus outer plus inner plus last, you could verify and you would see that what we have here is the same as what we started with.